Here is a worksheet to understand application of rules for finding indefinite integrals. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have the third worksheet on finding integrals. We are exploring basic integration techniques using 9 rules, right? So here are 4 questions for you. Integrate 2 cos x minus 3 sin x dx. Integrate 2x e to the power of 5x plus 3 minus 1 over x with reference to x dx, right? So likewise, we have 4 of them. Now they involve trigonometric and exponential functions. To solve these, we'll look into the basic rules which relate to the exponential and trigonometric functions. So here are the rules for you with examples, right? So this is the rule and that is how it is to be applied. Basically, we are deriving these rules from anti-derivations. So derivatives, when integrated, gives you the function back, right? So 6, 7, 8, 9. And then these are 10, 11, 12. Well, earlier in our worksheet, we did first 5 rules, which here is a quick reminder for you. So these are the basic rules which can help you do integration for straightforward functions. So let's practice these first, and then in the following videos, we'll learn special techniques to easily perform this operation of integration with respect to x, right? I'd like you to pause the video, answer these questions one by one. Here are our solutions. Question number 1. So we need to integrate 2 cos x minus 3 sin x with reference to x. So let me rewrite this expression, which is 2 cos x minus 3 sin x with respect to x, right? So dx tells you with respect to what variable. Variable clearly is x, and that's the sign of integration, right? Now, what is the integral of cos x? Well, integral of cos x is sin x. So we could write this as, well, first you could split them and write as 2 cos x dx minus integral of 3 sin x dx. Is that clear to you? So that is a rule for integration. You can add and subtract the terms. Now, constant multiplier remains as a constant multiplier. Integral of cos x is sin x. So we get this as 2 sin x dx minus integral of sin x is minus cos x. We get 3 times minus cos x. And these are indefinite integrals since we are not knowing the initial conditions. So we have to write plus c always, right? So now you can write the final answer, which is 2 sin x. Well, no need to write dx, that was a mistake. So 2 sin x minus and minus becomes plus 3 cosine x plus c. So that is the answer for question number 1. So I hope it is simple, straightforward. We simply applied the rule, correct? So we applied the integral of sin x and also integral of cos x formula to get the solution for question number 1. Now let's take up the next question, which is involving exponential functions. So let me rewrite this. It looks kind of complex. So we have 2x e to the power of 5x plus 3 minus 1 over x, correct? We have to integrate with respect to x. Look here. We can write each term separately, right? So that is to say, integral of 2x e to the power of 5x plus 3 over x dx, right? Minus integral of 1 over x dx. Is that clear to you? Now you can simplify, cancelling x in the first term, right? So you could cancel and simplify it. So what do you get? Well, in this case, you get integral of 2 e to the power of 5x plus 3, right, dx with reference to x minus integral of 1 over x dx. Is that clear to you? Now, integral of e to the power of ax plus b form it is. So it is what? It is 2 is a constant which remains as such. Then we have e to the power of 5x plus 3, right, divided by the derivative, right, which is 5 of exponents. Now here 1 over x is ln x, right? So that gives you ln. We write the absolute value of x and then plus c. Do you see that? So that is how you can write the integral of this particular function. So we have here 2 over 5 e to the power of 5x plus 3 minus ln absolute value of x plus c, correct? So let's move on and take the next question, which involves sine and cosine. Now let's rewrite the question, which is 3 cos of 2x minus 1. We can write them separately, right? Split them apart as like this, correct? No problems. So that is using the rules of integration. When you're adding and subtracting, you could do them separately and then add the integrals, correct? Now this is equal to, so constant 3, integral of cos x is sine x. So the argument here is 2x minus 1. You have to divide by 2, right? Now in this case, sine 5x, the integral is minus cos 5x over 5, right, plus c, the constant, right? So we get here 3 by 2 sine of 2x minus 1, and that becomes plus cos of 5x, 1/5 you can write here, plus c. Do you see how easily you can apply these rules and the answers? Perfect. So we've done 3 of them. Here is the last question for you. Integral of secant square x. Let's rewrite the question, which is 4 secant square. The argument this time is 3x plus 2. Integrate with reference to x, with respect to x or with reference to x. So integral of secant square x is tan x, correct? So we get tan of 3x plus 2 dividing by the derivative of inside function plus the constant c. So that is how we should be integrating with respect to x, applying the rules, right? So the rules 1 to 5, 6 to 9, and 10 to 12 are there before you. So I hope that kind of gives you good foundation to begin with integration and how do we apply these rules. In case you want to learn from me, you can always contact me using this email. Also, contact us on the website for the latest updates. Thanks for your time and all the best.